In this video, I'm going to go over the Unit 1 review that I assigned in AP Classroom. Feel free to skip ahead to any of the parts that you might need. So for this equation, we've got this graph right here, and that's the majority of what we'll be looking at. And we're asked about this function f of x, which is 3x plus the integral from 0 to x of g of t dt, and g is the graph that we have here. So part A asks us for f of 7. So for f of 7, we're just going to plug in 7. And when we plug in 7, we'll have 3 times 7 plus, and we're plugging in 7 for the x, not the t, there. So it's integral from 0 to 7 of g of t dt. And so 3 times 7 is simple. We've got 21 right there. And for this next part, we've got the area under the curve from 0 to 7. And the area is going to be negative right here from 0 to 6. But then from 6 to 7, we're going to have a positive area here, just this rectangle right here. So the negative area, we're going to have negative 1/2 pi times 3 squared. That's a semicircle, so half of pi r squared for that. And then for the positive part, from 6 to 7, we've got a little rectangle right here that's 1 by 3. So that's going to just be 3 right there. So you don't have to simplify it any more than that right there. You could just leave it like it is right here. If you want to simplify it, 21 plus 3 is 24. And 3 squared is 9, so you'll get minus 9 pi over 2. And that's the simplified answer. You could give a decimal on this, but there's really no need to do that. Now, we also have to find f prime of 7. And so for f prime of 7, we are going to have to find f prime of x. So if we take the derivative of f of x, f prime of x is going to be the derivative of this 3x right here is 3. And then this is the fundamental theorem of calculus. When we're taking the derivative of the integral, we're going to take this x right here and plug it in for our t, and then we will multiply that by the derivative of the x. So basically the derivative and the integral more or less undo each other. And so we'll get g of, instead of t, we'll have an x. And then we would multiply by the derivative of x, which is just 1. Here, and we can use that every time we take the derivative of an integral, as long as the number right here on the bottom is a number and not a variable there. And so we just are essentially getting 3 plus g of x. And so if we want to find f prime of 7, we are going to find 3 plus g of 7, and oops, let me cut that off. Sorry. G of 7 is going to be 3 right here. That's just the y value whenever x equals 3. So we've just got 3 plus 3, and that will give us 6. So f prime of 7 is 6. That part is worth 2 points. You get 1 point for f of 7 and 1 point for f prime of 7. So you have to have the answers right on both parts of that. Okay, let's go on to part B. For part B, I think B is a little bit difficult. It says find the value of x in the closed interval from -4 to 3 at which f attains its maximum value. Justify your answer. So if we're looking here from -4 over to 3, it is difficult to tell where the maximum value is at, because they're not asking us about the maximum value of g of x or g prime or anything to do with g. We're asked about f of x. So what we're going to do, if we want to know where we have a maximum, we can take our derivative and tell where that derivative is positive or negative. So f, oh, sorry about that. Let's go back and erase that. So we just found the f prime of x is 3 plus g of x. So let's just think about what that would look like right there. If I've got that g of x and I add a 3 to it, all that's going to do is take that graph and move it up 3 units. So let me see if I can get a picture of this over here. Uh-oh. I don't know what I did. Oh, this one. Okay, let me go back. Let me take a picture of this graph. Okay, that part is not working. Full screen. Alright, this is not working. Sorry about that. Try to take this out of the video. Okay, sorry about that. So, if we take that graph and we move it up 3 units, I'm just going to draw a real quick graph of what that would look like. If we move everything up, then we would have this graph right here, something like that. That looks really terrible. But this graph would just barely come down and touch the x-axis right here at 3. And so if we're thinking about this value, 3 plus g of x, for negative 4 to 3, f prime of x would have to be greater than or equal to 0. And that would be because 3 plus g of x would give us a positive number everywhere until we get right here to, or even there, it'd be positive. So, because 3 plus g of x would be positive numbers here. And so, if, therefore, f of x increases on negative 4, 3. And so if f of x increases the whole entire time from negative 4 to 3, that means that the maximum point must be at 3. So we could say, so f attains its maximum point at x equals 3. So, that would be our reasoning for that question. That would have the maximum point x equals 3. If we look at this, this is worth 2 points. You get the answer with justification. So you have to say it's at 3, and you also have to give the justification with it. You're going to have both to get those points. Okay? If we go back up here to 3. For 3, it says, for each of these, find the value or state that it does not exist. So, we're looking at the limit as x approaches 0 from the left of g prime of x. So, for part C, we're looking at the limit as x approaches 0 from the left of g prime of x. Now, whenever we look at this, remember this is the graph of g that we're looking at here. They are asking us about g prime, which is the slope of g. This has nothing to do with f this time. We are only looking at this graph. So if we're looking at the slope from the left right here, then the slope from the left is going to be negative 1/2. So negative 1/2 is that slope. And all the way up to that point right there at 0, 0, the slope of that line is negative 1/2. So that limit as x approaches 0 from the left of g prime of x is negative 1/2. Now, we also have to consider the limit as x approaches 0 from the right of g prime of x. Okay, now from the right, this is not as easy because you've got a circle here, so you can't find the slope really easily like when looking at a line. But if you think about what you know about a circle, right here at this bottom point of that circle, you would have a horizontal tangent. So over here at this furthest point of the circle right here, you're going to have a vertical tangent. And the slope of any vertical line is undefined. So this limit right here does not exist. And it does not exist because that slope at that point would have to be vertical. And vertical tangents are undefined. They do not exist when we're talking about a limit. Okay, I believe that one is a point apiece for each answer as well. And then so let's look at the very last part for part D. D says to find the limit as x approaches negative 2 of f of x plus 7 over e to the 3x plus 6 minus 1. And so right here, that is a terrible limit that we don't know how to do just traditionally by evaluating it. But this is a situation where we can apply L'Hopital's rule. However, to apply L'Hopital's rule, L'Hopital's rule is the rule that tells us if we take the derivative of the numerator and the derivative of the denominator, then we can plug in our negative 2 and get our limit. But L'Hopital's rule only applies if the limit of the top is 0 and the limit of the bottom is 0. You cannot just say this equals 0 over 0. That will not get you credit on this problem. So we do not want to do that. I do that a lot, but it is mathematically incorrect. So what we have to say is we have to say the limit as x approaches negative 2 of f of x plus 7 equals 0. And let's look at why that equals 0 here. Here we would be doing 3 times negative 2 plus the integral from negative 2 to 0 to negative 2 of g of x dt. And so actually let's just work that out so you can believe me that that does equal 0. You don't necessarily have to show your work here, but you would be doing this would be 3 times negative 2 plus the integral from negative 0 to negative 2 of g of t dt plus 7. So this would be negative 6. I'm going to write this as minus the integral from negative 2 to 0 of g of t dt plus 7. And here, the area under the curve from negative 2 to 0, that's going to be, we'll have negative 6 minus 1/2 times 2 times 1 plus 7 here. So we get negative 6 minus 1 plus 7, and that is going to give us 0. So you don't have to show all that work, but that just shows us here that limit is 0 for the numerator. Then you also have to show that the limit of the denominator is 0. So we would do the limit as x approaches negative 2 of e to the 3x plus 6 minus 1. And so that would be e to the 3 times negative 2 plus 6 minus 1. And 3 times negative 2 is negative 6, plus 6 is 0, so you've got e to the 0 minus 1. E to the 0 is 1, so 1 minus 1 equals 0. So we have shown that the limit of both the numerator and the denominator equals 0. That must be done in order to apply L'Hopital's rule. So now we could say by L'Hopital's rule, and now we can do the limit as x approaches -2 of f prime of x. We're taking the derivative of the numerator. And then we also want to take the derivative of the denominator. Derivative of e to the 3x plus 6 is e to the 3x plus 6, but you have to multiply by the derivative of 3x plus 6, which is 3. You've got a chain rule there. The derivative of -1 is just 0, so that goes away. So now we've got this limit right here. Now if we plug in here the limit as x approaches -2, actually, let me just go ahead. I don't have to write that limit notation anymore because I'm going to plug in my numbers. So this is going to equal f prime of -2 over 3e to the 3 times -2 plus 6. And so if we go up here to our graph, f prime of -2 right here, that's the slope of, actually don't go to your graph because we have to use the derivative of f. So the derivative of f was 3 plus g of x, so we'll have 3 plus g of -2. Don't go to the graph there yet. And then in the denominator, we've got 3 times -2 plus 6 is going to be -6 plus 6, which is 0. So we've got 3e to the 0. And so we've got 3 plus g of -2 right here is 1. So 3 plus 1 over 3 times 1. And that will give us 4 over 3. And so that is our limit for this particular situation. So that gives us all of our parts for this one. Let's just look real quick. That part counts for 3 points. So you get a point for showing that the limits equal 0. You get a point for applying L'Hopital's rule. So that's taking the derivative of the top and the bottom. And you have to use that phrase that's L'Hopital's rule. And then a point for the answer right here. I did not spell this with the S. Some places spell it with the S, some do not. They have said the spelling does not count on the AP exam. So if you get something close to the hospital's rule there, then you're good enough for that one. So that's the first problem. Let's go to the second. All right, this problem tells us that we have a continuous function f, and it's defined on this closed interval. We know here that it consists of 2 line segments, so these parts right here are lines, and then we have a quarter of a circle right here. It is known that the point 3 minus square root of 5 is on the graph. So 3 minus square root of 5 is right here on that graph. So if the integral from -6 to 5 of f of x dx equals 7, find the value of the integral from -6 to -2 of f of x. So remember, this is our graph here. We do know here then that the integral from -6 to 5 of f of x dx equals 7. So that is the area under the curve on this from -6 up to 5. Well, -6 is not on the graph. So we're asked to find basically this part that's not on the graph. So what we need to do is we need to find the integral from -2 to 5 of f of x. And then we can subtract it from that 7 that we have. So the first little part that we have is we've got this little tiny triangle right here that's positive. So that's going to be 1/2 times 1 times 1. And then we're going to have this little negative portion right here. And so that is going to be negative 1/2 times 1 times 1.5. I'm going to write that as 3/2 there. And then the next part that we're going to have a triangle right here. And in that triangle, let's go down here to the next line. Hold on a second. Okay. So this area right here, this triangle, we're going to have 1/2 times 1.5, which I'm going to write as 3/2, times a height of 3. And then this last part is also positive. And it's a little hard to do because you've got to take, basically you're taking this rectangle right here and you're subtracting the circle part. So the rectangle would be 3 by 3, so it's 9. But then you've got to subtract that quarter of a circle, so it's 1/4 times the radius, which the radius of that circle is 3, squared. Now, on the AP exam, you could leave that in, so let me, we're going to simplify this. Now, you can use the calculator for this if you want or not. This is going to be 1/2 minus 3/4 plus, right here we're going to get 9/4 plus 9 minus 3 squared is 9, so 9 pi over 4. So if we do that, let's see, we'll have, let's see, this is 2/4 right here. So we got 2 minus 3 will give us -1, which will give us 8 over 4. And 8 over 4 will be 2 plus 9 will give us 11 minus 9 pi over 4. And let me double check, 11 minus 9 pi over 4. That would give us 3.931. If we want to go with a decimal on that, I think I'm going to go for a decimal. So 3.931 for that. So that is our integral from -2 to 5. So we know that the integral from -6 to -2 of f of x dx plus the integral from -2 to 5 of f of x dx should equal the integral from -6 to 5 of f of x dx. So we do not know this first integral, this one that we're looking for, but we just found the second one, which was 3.931, and the problem told us that the integral from -6 to 5 of f of x dx is 7. So to solve this, we can do it really simply by just subtracting the 3.931. And so our integral from -6 to -2 of f of x dx equals 3.069 whenever we subtract those. So that's our part A over here. See if we can get this to come back where we can see it a little better. Okay. Alright, so for part B, it asks us to evaluate the integral from 3 to 5 of 2f prime of x plus 4 dx. So let's do that here. For B, we want the integral from 3 to 5 of 2f prime of x plus 4 dx. So if we integrate 2f prime of x plus 4, 2 is just a coefficient here. The integral of f prime of x is f of x. So we're going to get 2f of x here. And then when we integrate 4, we're going to get 4x. And that's going to be from 3 to 5. And so we're going to plug that in. We're going to have 2f of 5 plus 4 times 5 minus 2f of 3 plus 4 times 3. And so from our graph that we're given, this is our graph of f, so f of 5 is 0, so this is 2 times 0 plus 20 minus 2 times f of 3 is right here at an obscure point that we don't think we know, but remember they gave us some extra information in the problem. They told us that it goes through the point 3 minus square root of 5. So this is 3 minus square root of 5 plus 12. Now, AP exam, stop right here. You're done. But I want to check to make sure my answer matches what they've given, so I'm going to go ahead and simplify. 2 times 0 is 0, so I just get 20 right here. And then here I'll get 6 minus 2 root 5 whenever I distribute that 2 plus 12. And so we get 20 minus, if we add that 6 and 12, we get 18 minus 2 root 5. And so that'll be 20 minus 18 plus 2 root 5. So we will get 2 plus 2 root 5 for our answer. Again, on the AP exam, you can stop right here. You cannot stop up here before you plug in these values of f of 5 and f of 3. You have to plug those values in to show you know those come from the graph. But after you plug in and all you've got is numbers, you can stop and you don't have to simplify after that. But we should get 2 plus 2 root 5. Let me check down here to see if that looks like it's right. 2 plus 2 root 5. That works fine. Yep, this is the way that we did it right here. So that looks great. All right, let's go on to part C. Part C says the function g is given by g of x equals the integral from -2 to x of f of t dt. Find the absolute maximum value of g on the interval from -2 to 5. Justify your answers. So this is something we've been seeing a lot on our problems lately, is an absolute maximum. And an absolute maximum happens either at a critical point where we're switching from positive to negative on the derivative, or it happens at an endpoint. So don't forget, for these you have to check your endpoints in this case. So for C, the first thing we want to say, if g of x is the integral from -2 to x of f of t dt, then g prime of x is going to be a derivative and an integral undo each other, so just f of x times the derivative of x, which is just 1, so you don't have to put that there. So f of x is the derivative of g. So let's go up here and look at our graph of f. And so of f, we've got a point right here where our derivative of g, or f of x, switches from negative to positive to negative. So this is a candidate for our maximum. And then we don't have any other points, but over here at 5 could also be a maximum, because if this graph kept going, it could almost switch from negative to positive. It would not be right here because we know that the graph is increasing from -2 to 1. We also know this would be a minimum point. So we want to know our possibilities are at x equals -1 and x equals 5. Now, the good news is we already found the value for 5. So g of 5 would be the integral from -2 to 5 of f of t dt, which we already found in part A. Right here, all of this stuff right here, -2 to 5, we found that that was 3.931. So we're just going to write down, we're not going to do the work again, 3.931. 3, 1. But we do have to find g of 1. Okay, so g of 1 is going to be the integral from negative 2 to 1 of, negative 2 to 1 of f of t dt. And so area under the curve from negative 2 to positive 1. I'm sorry, should be negative 1. And so if we look at that, this is a negative 1. That was our possibility right here. So if we go back up here, from negative 2 to negative 1, we just have that tiny little triangle, which is going to be 1/2 times 1 times 1, which is just going to give us 1/2. And so since g of 5 is greater than g of negative 1, then we know, did it ask for x values or, okay, it does not ask for the x value where this absolute maximum occurs, but asks for the absolute maximum. So, so we could say the absolute maximum of g of x occurs at x equals 5. It's a 5 right there. And is, let's see, it was the 3, what was it? 3.931. 3.931. Okay, so your absolute maximum is 3.931 for that. And let's double check that we got that one right. Okay, 11 minus 9 pi over 4 is your 3.931, so that is your maximum there. Alright, we've got one more section to do for this one, for part D. This is another L'Hopital's rule problem, because that limit is nearly impossible to do without using L'Hopital's rule. So L'Hopital's rule, you always have to tell the derivative, the limit of the top and the limit of the bottom equals 0. So we'll first do the limit, that says limit right there, of as x approaches 1 of the numerator, so 10 to the x minus 3 times f prime of x is going to equal, and so it's going to be 10 to the first power minus 3 times f prime of 1, and our graph up here, f prime of 1, right here at 1, we have a slope of 2, so we're going to have 10 minus 3 times 2, which is going to give us 4. Actually, I take this back. This is not a L'Hopital's rule problem. They use L'Hopital's rule often for these problems, but this is not going to be L'Hopital's rule because you do not get 0 there whenever you plug that in. So, this is actually just a plug-in limit problem. So we can do the limit as x approaches 1 of 10 to the x minus 3f prime of x over f of x minus arc tan x. And we can just find the value for this. So we're going to have 10 to the first minus 3 times f prime of 1 over f of 1 minus arctan of 1. And so this is going to be 10 minus, as we just said, 3, and then again the f prime of 1 is 2, because the slope of this graph right here is going to be 2 at x equals 1. So 3 times 2 right here. F of 1, this isn't looking for slope, but rather just the y value whenever x equals 1. So that is 1 minus arctangent of 1. And so arctangent 1 is inverse tangent. You could just do that on your calculator since it's going to be allowed. Inverse tangent of 1 is pi over 4. And then you can just leave it right here. Or if you would rather, you can do, you'll get 4 over 1 minus pi over 4. I definitely would not simplify it any further than that. Let's check the key to see what it gives us for part D. And so they just leave the answer like this as well, 4 over 1 minus pi over 4. So that is your answer. It initially looked to me like it would be a L'Hopital's rule problem, but when you take those limits of top and bottom, you don't get 0. So you can just plug in the numbers for that one. All right, so if you have any other questions, let me know. I hope this helps.